Welcome to Mickey Study Circle channel. In this video, we shall see how to do the manual drafting of the orthographic projection of solids. So here we take up a problem on pentagonal prism, which is resting on one of its base edges, and the same edge is also inclined to the vertical plane at 30 degrees. And with respect to the horizontal plane, the prism is having its axis inclined at an angle of 40 degrees. So let us read the problem statement once to understand the data given in the problem. So the problem statement goes like this, wherein a pentagonal prism 25 mm sides of base and 60 mm axis length rests on HP on one of its base edges, which is inclined to VP at 30 degrees. Draw the projections of the prism when its axis is inclined to HP at 40 degrees. So this is the problem statement. So how do we analyze the key points from this problem statement? So the first thing is the type of the solid. It is a pentagonal prism. And next comes the resting condition, which tells that it is resting on one of its base edges. Next comes the inclinations. So with respect to the HP, the axis is inclined at 40 degrees. That is the value of theta. And with respect to the VP, the edge is inclined at 30 degrees. That is the edge on which it is initially resting. And next we do calculate the base inclination angle as 90 minus theta. So we are going to incline the base of the prism at an angle of 50 degrees so that the axis is inclined at an angle of 40 degrees. And also here the edge on which it is resting is taken for inclination with respect to the VP, and therefore it becomes a non-beta angle problem because the parameter is not going to change. That is, the edge length is going to remain 25 mm in its first position as well as second position, and hence we are going to consider this parameter for inclination with respect to the VP, and hence it is a non-beta angle problem. So now let us see how the solution is drafted. So let us begin by constructing the XY line. So the XY line, the projection lines and the visible lines. So these are the key points that we need to understand in the construction. So now let me begin the construction by drawing the XY line. So I'll draw a straight line and annotate this line as X and Y, and the reference planes as the vertical plane VP followed by the horizontal plane HP. So this part is over. So now let us move towards construction of the initial position. So first let us proceed towards constructing the pentagon prism, the top view of the pentagon prism, wherein it is resting on one of its base edges. So for that, let us consider drawing the first edge of the pentagon, which is equal to 2.5 centimeters. So at a comfortable position, let me begin the construction. So it is at 2.5 centimeters. So this is one of the base edge which is perpendicular to the XY line. Now keeping this base edge as the reference, I'll be constructing the other edges. So from one of the extreme corner, I'll be marking 108 degrees, that is the exterior angle. The interior angle will be measuring 72. Here I'll consider the exterior angle as 108. So I'll just mark a point at 108. And similarly, at this extreme point of the base edge, I'll be considering the angle of 108 degrees. So just mark the points for your reference and then proceed towards constructing the edge length of 2.5 centimeters at that marked angle. So this is one of the base edge which is measuring 2.5 centimeters. Similarly here, I'll repeat the same step. I'll be constructing the line which measures 2.5 centimeters. So this is 2.5 centimeters. So now construction of the remaining two edges. I'll use the compass for this. I'll just measure the distance from this point, that is the corner point of the first edge, and next the corner point of the second edge that we have constructed. So let me keep the compass here and then cut an arc like this. And similarly, this edge I'll be considering. Measure this edge. I'll keep the compass here again and then I'll cut an arc. So now the point of intersection is where I'm going to draw the two other edges. So you can just see that it is exactly equal to 2.5 centimeters. So now I complete the construction of the pentagon resting on one of its base edges. So this is the top view of the pentagon resting on one of its base edges. So let us just annotate the pentagon prism. So let us tell that it is resting on one of its base corners A1, B1. So A1, B1 will be the bottom face, which is not seen. So AB will be the base edge of the top face of the prism, and this is A1, B1 inside the bracket. Similarly, C, C1, and next D, D1, and E, E1. So the checkpoint here is I've considered the edge towards the right hand side, which is very important. And next is I need to mark the axis. So to get the axis, I require the centroid of this particular prism where the axis is going to originate. So how do I mark this? I'll consider the corner point and the edge opposite to that corner point. So the edge is 2.5 centimeters. So I need to locate the midpoint of this 2.5 centimeter line. So it will be around 12.5 mm. So I cannot mark 12.5 mm. So somewhere between 12 to 13 mm, I'll be locating a point and mark the center point of this particular edge. So now I'll just using a very thin line, I'll be drawing the median. Okay, and I'll repeat the same step. So I can consider any corner, but remember to consider the edge opposite to that corner. So I'll consider this corner D1 or D, and I'll locate the midpoint of this particular edge, that is the opposite edge, at between 12 and 13 mm. So just draw two medians, and the intersection point of these two medians will mark the origin of the center, origin of the axis. Okay, so now let me draw the projection lines. So this marks the centroid of the prism from where the axis is going to originate. So this is O1. So O is the center point of the top face, O1 is the center point of the bottom face of the prism. Similarly, from the other edges, let me draw the projection lines. So C and E, it will be having a common projection line and a separate projection line for the corner D. So now, as per the problem statement, the axis measures 60 mm. So let me construct the 60 mm line in the front view, which marks the axis of the prism. So I'll be using the chain line for the construction. So this is the axis line. Now let me complete the prism front view. So first, by joining the extreme endpoints, I'll mark the base of the prism. And next, all the other corresponding edges will also measure 60 mm, that is 6 centimeters in length. So this is one rectangular edge. And similarly, the corner D. And next, this edge is also visible. So this is the second rectangular face. So I'll be able to see two rectangular faces like this. let me complete the top face of the prism by drawing the projection line. So this completes the front view of the pentagonal prism. So now let us proceed towards the annotation part. So this marks the bottom of the prism and this marks the top portion of the prism. So this is B1 dash and A1 dash inside the bracket. Similarly, this marks the top face, that is B dash and A dash. And this point is O1 dash and this point is O dash. And similarly, this is C1 dash inside the bracket E1 dash. And here it is C dash and E dash. And here it is D1 dash and this point is D dash. So this completes the initial position, wherein you can just see that a pentagonal prism is resting on one of its base edges. Now let us move towards the second position, wherein we are going to incline the base of this particular prism at an angle of 50 degrees, so that as per the given condition we'll be having the axis inclined at an angle of 40 degrees. So I'll just consider marking one reference point and then draw the 50-degree line. So I'll consider this as the reference point, and on this from this reference point I will draw a line of 50 degrees angle. Correct. So this is the construction line or the projection line. Okay, so remember all these must be having the least thickness. Now I'll transfer the base of the prism. So the base of the prism measures around 40 mm for me. So I'll transfer this 40 mm line, which is the base of the pentagonal prism, on this 50-degree line. So the base is imported there. So now from the extreme right corner towards the axis, I'm going to measure the distance. So it is around 1.9 centimeters. So I'll mark that point as the axis point. And next, from the extreme right corner point, the next rectangular face is at a distance of say 2.5 centimeters. So I'll mark that point also. Correct. So now the reference here is 90 degrees. So let me just measure 90 degrees from all these points. So this is the 90-degree point here. Okay, and I'll be transferring this 60 mm at 90 degrees. Similarly, from this point it is the axis, and the axis is also at 90 degrees. So I'll mark the 90-degree line and I'll construct the axis line using the chain line, which is also measuring 60 mm. And I'll be constructing the next edge at 90 degrees. So take a protractor from the next rectangular edge line, mark an angle of say 90 degrees and draw the 60 mm line. Similarly, from this extreme corner, mark 90 degrees. And complete the construction of the rectangular faces that is seen in the front view of the pentagonal prism. So now I'll be joining all this lines. So that should also be 90 degrees. So you can just align your scale. Okay, so this completes the construction of the front view of the second position. Now let us immediately go for annotating this. So this is the reference corner B1 A1, which is used for rotation, and this is O1 dash, and this is O dash. Similarly, this was B dash and A dash, and here we have got the edges C1 dash and E1 dash, and here it is C dash and E dash, and this is D dash, and this is D1 dash. Okay, so now if you want to measure, just extend this axis line to meet the XY line and measure the angle. So you can just see that it is exactly equal to 40 degrees, which is, as per the problem statement, the axis is inclined to HP at an angle of 40 degrees. So this marks the construction of the front view of the second position. So now let us complete the top view of the second position by drawing the vertical projections downwards and intersecting that with the projection lines from the first top position. So draw all the projection lines. Okay, so the vertical projection lines have been drawn. So now let us consider drawing the horizontal projection lines. So from A1, it will be intersecting the extreme projection lines that we have drawn. Similarly, B1, and next we will draw the projection lines from C and C1. And next from D1, it will be on this D1, O1, everything will be on the same straight line. So let us draw the projection line. And next from the corner E1. So now we have got the points. So now let us just do the annotations. So this is A, this is B, and from C we have got the point of intersection as C here, and E is also on the same line. Okay, so C will be on this line and E is on this line. So this is the corner point E, and next we have got D here, and this is O, and next is O1 dash. Okay, this is O1, and next we have got the other bottom face. So let us mark the points on the bottom face. So this is A1, this is B1, and similarly C1 line is here. So this is C1, and C1 E1 will be on the same line. You can just see here. So this is E1, and similarly this point of intersection is D1. So we have annotated the points. Let us complete the top view of the prism. So before we complete the top view, let us understand one more important point here. The corner B1 dash, A1 dash are the farthest corner points. So A1 to B1 will be dotted line. And all the other edges connecting from A1 to E1 will be also dotted. And next from B1 to C1 will also be dotted because A1, B1 are the farthest corner points. So now from C1 to D1 it will be visible, and next E1 to D1 will also be the outer edge of the prism, so it will be visible. Now let us complete the top face. So AB is a continuous line. Next is from A to E, and next is from B to C, and next is from C to D, and next we have got from E to D. So now the pentagon faces, bottom face and top face is ready. So again, since B1 is the farthest corner point, B1 to B will also be the dotted line. So we know that two thick lines shall not intersect. So therefore A1 to A is also dotted line. Next, the outer edges E1 to E will be the outer edge visible, and next D1 to D will be again visible, the outer edge, and next we have got from C1 to C. So this completes the top view of the pentagonal prism when it is having its axis inclined at an angle of 40 degrees to the HP, that is the horizontal plane. And you can just see that O1 to O is also there, but it will be overlapped by the outermost edge D1 and D, so the axis will not be shown separately here, but O1 to O will be the length of the axis. So now we need to continue with placing the prism on the 30-degree line, that is the edge on which it is resting should be placed on the 30-degree line. So A1, B1 is the resting edge, and now we need to consider rotating the prism in such a way that this edge A1, B1 on which it is resting initially is on this 30-degree line. So I've drawn a 30-degree line here. I've taken a considerable distance from the XY line so that this prism will not go above the XY line when I'm doing the rotation. So now let me construct this. So this is the 30-degree line that I've drawn. So I'm going to take the distance of A1, B1, which is equal to 2.5 centimeters. So I'll be transferring that 2.5 centimeters along with the hidden edges of 2.5 centimeters. And I'll label this. So this is A1 and this corner is B1. So now I'll proceed with the other constructions. You can just see that A1 to A and B1 to B, they're all straight lines, that is they're all at 90 degrees. So let me draw them as 90-degree lines. So I'm going to measure 90 degrees from both the corner points. And also from B1, I'll mark 90 degrees and I'm going to transfer these points. So let me take the measurement from A1 to A, which is equal to around 5 centimeters. So I'll transfer them as dotted lines itself. So A1 to A is transferred. So this point will be A now. So A1 to A is done. And similarly B1 to B at 90 degrees. So even this is dotted line from the second position. And this too will also be a straight line. So I'll just draw AB as the straight line. So annotate the points. So this is A1 and this is A and this is B. And now I need to locate the points, the other points or the corners, that is E1, C1, D1, E, D and C. So what I can do is, if I just see this a pentagon prism here, so A1 to A is transferred, B1 to B is transferred. If I have to locate the point E1 and C1, I can just see that E1 and C1 are on the same straight line. So what I'll do is I'll just consider the distance from A1 to this projection line, that is on E1 to E, and B1 to this projection line, that is C1 to C. I'm going to measure this distance and make an offset of this dotted line, that is A1A, to this distance, and from here I'm going to measure E1 to E. So that is how I can locate the points E1 and C1. So I can just measure here. See, from this point, that is A1 to A, I'm going to consider this distance, which is equal to roughly around 0.6 mm, and similarly B1 to this line is also equal to around it is equal to around 0.8, and here it is equal to 0.6, 0.7, and similarly here also it is equal to 0.8. So I'm going to measure that and transfer. So I'm going to mark these points, and again from here I'll be drawing this 90-degree line. So I'll mark 90 degrees and then 90 degrees here from this marked point. So now I'll take the measurement from this particular point. E1 is at a distance of 1.9 mm. So I'll mark a point at 1.9 mm and with reference to that of 90-degree point. So 1.9. And similarly from B1 to this point, that will also be equal to 1.9. So join the points, and similarly now we have got E1. So E1 to E is a straight line, and I'll take that measurement. So it is equal to 5 centimeters. So it is equal to 5 centimeters. Similarly, C1 to C will also be the same length of 5 centimeters. So I'm going to transfer that with 90 degrees as the reference point. So now these are the points, that is A1 to E, or A to E, and B to C. So now I need to locate the point D. So D, O1, D and O are all on the same line. So I'm going to measure, see here A1 to B1 is bisected, and from that midpoint only all these points I'll be getting. So what I'll do is I'll just mark the midpoint of this A1, B1. And from here I'll be marking 90 degrees again. So if I just measure this extreme point, so from here till here, if I have to measure to get the point O and D. So from here till here, the point D, or the corner D, is at a distance of 2.5 centimeters. So I'll locate 2.5 centimeters. So this is the corner D I've got. So let me join this. And next, from corner C to D. And next, if I just measure from this point to the point D1, it is at a distance of 2.5 mm again. So from this point I'll be taking 2.5 centimeters and getting this point. So I'll be joining this. And I'll extend this. So let me just annotate this. So AB is here, so this is A and this is B, this is D, and this is the corner E, and this is the corner C. Similarly, this is the corner C1, this is the corner E1, this is the corner D1. So now I need to identify the points O1 and O. So let me just measure from A1 to A1 B1 to this point O1. It is at a distance of 3.9 mm. So from here I'll be taking the distance of 3.9 mm and I'll just extend this line, and this is where the point O is lying. That is the axis of the top face of the prism. And next, from this distance to O, if I just measure, I'll be getting O1, which is exactly at 1 mm. So from this point, so this will be O1. So now I've completed the rotation of the pentagonal prism in such a way that the edge on which it is resting is inclined to the vertical plane at an angle of 30 degrees. So to show that angle, if I just extend this line, okay, so I can just draw one more parallel line to show the inclination, which is equal to 30 degrees. So now let me draw the vertical projections from each of the corner points. So let me first consider drawing the projection lines from LHS to RHS. So from O1, I'll be taking a projection line. And next we'll be drawing one more projection line from C1 and E1. And next from D1. So now let me take the projections from the top view to the front view. So A1, B1 is on the XY line. A1, and this is B1, A1 dash, this is B1 dash. Similarly, from C1, intersect the projection line of C1, so this is C1 dash, and next D1, draw the projections from D1, and this is D1 dash. Similarly, I've got the projections from E1, which is again on C1 projection line only, so this is E1 dash. And from point O, I've got the axis line here, and this is O1 dash. So now let me complete the bottom face of the prism, which is completely visible. So I'll start from A dash to B dash, and then B to C. The distance will be very small, so take enough care that you make it properly. And then C dash to D dash, then from D to E, that is D dash to E dash, and next from E dash to A dash. So this completes the bottom face of the prism, which is visible to the observer, because the observer is going to look like this. So the complete bottom face is visible. So now I'll adopt the same procedure and complete the top face also. So from B dash A dash, I'll draw one projection line. Similarly, from O dash, I'll draw one projection line. Similarly, from C dash E dash, I'll be drawing one projection line. And next, D dash. I'll draw the projection lines from the top view. So from point A or from corner A, this is the projection line from the corner A, projection line from the corner B. So this is B dash and this is A dash. And also from the axis O, so this is O dash, and next from the corner C, which is here, so this is C dash, and next from the corner D, which is this corner D dash, and next from the corner E, and this is E dash. So now the farthest corner point for the observer is the corner A. So from the corner A, all the edges will be hidden. So A dash to B dash is hidden, and similarly from A dash to E dash it will be hidden, and also A dash to A1 dash will be hidden. Right, so now all the other edges we can complete. So B to C will be visible edge, and then we have got C dash to D dash, and then we have got D dash to E dash. So now we'll just complete the outer edges. So D dash to E dash, a straight line, and next E dash to E1 dash, connect all the parallel edges, C1 dash to C dash, and then B dash to B1 dash is a straight line. So this completes the front view of the pentagonal prism. So let me draw the axis from O1 to O using the chain line. So this is the axis from O1 to O. So if at all you are supposed to measure the apparent length of the axis in the final position, O1 to O will be the apparent length, and this is the view of the pentagonal prism when it is having its resting edge inclined to the VP at an angle of 30 degrees. So with this we complete the problem. So you have to identify the farthest corner point. So the farthest corner point for the observer is the corner A. So from the corner A, all the lines will be dotted, that is A dash to B dash. So let me just write it here again. So this is A dash to B dash, and A dash to E dash, A dash to A1 dash. So this is A1 dash. So how do you validate this if it is correct? So initially it is resting on which edge? A1, B1. In the final position also it is on the edge A1, B1. So with this we complete the problem. So you can just see that A dash to A1 dash is hidden, A dash to E dash is hidden, A dash to B dash is hidden, and rest are all the thick lines or the continuous lines which are visible to the observer. So the bottom face of the prism is completely visible, whereas in the top face only these outer edges are visible, and this edge is not visible, so it is in the dotted line, and O1 to O is the axis in the final position. So with this we complete the manual drafting of the problem, wherein a pentagonal prism is initially resting on one of its edges of the base, and its axis is inclined at an angle of 40 degrees to the vertical plane, and then the edge on which it is resting is inclined to the vertical plane at an angle of 30 degrees. Thank you all for watching.